Hey, Castle here, and welcome to Memphis Communiversity. Today we're going to be talking about the Intermediate Value Theorem and the Mean Value Theorem, or IVT and MVT. That's how I'll refer to them for this video. So this is kind of a weird topic because these aren't really formulas like a lot of the other things we do in calculus. These are called existence theorems, and that basically means that instead of solving for a certain number like we usually do, we're actually just proving that a number exists. So depending on the way that a question asks, we're either going to prove the existence of a number using IVT, which I'll show you on that first one, and using MVT, which I'll show you on that second problem. So these first two are really just stating the theorems. We're not actually solving a problem. So these are really important, and the sentences that I'm going to write on these are kind of going to serve as templates for all the example problems. So make sure you pay close attention to both of those, and we're just going to start with IVT. IVT is kind of a weird one because it's not really a calculus topic. You're not taking derivatives of anything. You're just basically writing a sentence to prove that a number exists. So I'm just going to start with the first part of this sentence that you have to write. And the first part says, if f is continuous on the interval a to b, so, oh, am I paused? Hello, okay, I'm unpaused. Hopefully you got all that. The first condition that we have in this sentence is f has to be continuous on the interval a to b. So that just means that from this x value to this x value b, there has to be a y value associated with every single x point in that interval. And you can see that on the graph. When you've got your graph from a to b, you don't have any holes in the graph. You have a point, you have a y value for every x value in there. So f is continuous on a to b. And then the second condition that you have to write out is and n is in between f of a and f of b. So as I'm writing that, I'll just kind of point it out on the graph. You can see here that you've got f of a, that's the y value associated with the x value a, and you've got f of b, the y value associated with b right here. And then you have n, and that's a y value between f of a and f of b. And again, this is kind of a template that you're going to use for other things. So the things like a, b, n, all of those are going to change depending on the questions that's asked. But here, n can be any y value as long as it's between f of a and f of b. So that's the second part of the sentence. And then this last part of the sentence is where IVT really comes in, because this is when you're actually writing out the existence of a number. So what you're going to write is, then there exists a number c in the interval a to b. So I'll just point that out on the graph as I'm writing it. There's that c in between a and b. So you're proving with IVT the existence of an x value, and in this case that x value is called c. And then to finish it off, you say such that f of c equals n. So I'm just going to reread that out and kind of point out things on the graph as I talk about it. You've got f being continuous on a to b. There's a y value for every x value there. And n is in between f of a and f of b. You have that y value somewhere in between these two y values. Then there exists a number c such that in a to b, such that f of c equals n. So basically IVT is saying that for any y value in between f of a and f of b, there has to be an x value associated with it, so long as that y value is between those and this function is continuous. So what I underlined here is just the things that are going to change depending on the example problem. So I have a, b, n, things like that, but those are all going to be real numbers once we start working. But c actually is not going to change. C is always going to be a constant because, like I said, you're not solving for a number. This is just an existence theorem. You're proving the existence of a c. So, like I said, basically you're trying to say that for any y value in this, between these two y values, it has to have an x value associated with it. So this y value doesn't have to be where n is on this graph. It could be right here, and then it leads to this point and has an x value down here, or it could be right here and leads to this point. You're just proving the existence of that c, that x value. So that'll make a lot more sense once we start working through some of our example problems. But just remember that IVT, you're not using calculus, you don't take any derivatives, and you're just showing that a number exists between two other numbers. And so I'll just write that up there. So the next thing that we're going to be doing is the mean value theorem. And the mean value theorem is different from IVT because you're actually going to be using calculus, you're going to be taking derivatives. And instead of showing that there is a number between 2 points, you're trying to show that, you're trying to show with MVT that two things actually equal the same number. So let's work through this one. First, I'm just going to kind of point out some different things on this graph. I have this line drawn. I've got a graph between A and B. And the line, if you connect the points from A to B, is called the secant. And then I have an x value C written at somewhere between A and B. And then you're going to bring that C up and draw a tangent line, which is just a line that's parallel to that secant line. So basically, on MVT, what we're going to be proving is that this tangent line and this secant line are parallel. And remember that parallel means the same slopes, so that's where trying to find the same number comes in. So the first thing that I'm going to write, the first condition for the MVT sentence is if f is differentiable. So that just means that every x value on the graph of x has a derivative, or every y value has a derivative, which means it has a slope. So if you look at here, if you look at this graph, then you could take the slope of any point on this line between A and B. And also remember that differentiability implies continuity. So if something's differentiable, it's also continuous. So you don't have to state that it's continuous, but you can see that it is. Every single x value has a matching y value, and you can take the slope of any of those y values. So that's the first thing that you write. If f is differentiable, well, if it's a differentiable function, I left out that a right there, on A to B. So I'm going to write that out. And what I wrote here was if it's a differentiable function on the closed interval A to B, and I'll point that out later, but let's just move on to the next part. What I'm writing here is then there exists a number C between A and B. So that's pretty similar to what we wrote on IVT, because on IVT you're also looking for a certain C between A and B. But for IVT, what you're looking for is a C that leads to a y value between two other y values. In this case, you're looking for a C between A and B that leads to a slope that matches with the slope from A to B, that secant line slope. So finishing off the sentence, I wrote, if f is differentiable and on the closed interval A to B, there exists a C between A and B such that f prime of C equals, and that's that basically just the algebra slope from A to B. So what I wrote here is f prime of C, basically saying this tangent line, the slope of C, equals the secant line slope, the slope from A to B. So the essence of MVT is basically that somewhere on this line, this secant line and a tangent line have a parallel slope, meaning the slope is the same. So we're trying to find that point, that x value, where the tangent line and the secant line have the same slope. So this makes sense because I have f prime of C, basically the tangent line slope, and then I have this, what I call the algebra slope. I'll just keep calling it that. And that just means the slope of the secant line. And when they equal each other, the number of this one is going to equal the number of this one because they have the same slope. So on the MVT, we're trying to show that two different slopes, or that two different lines have the same slope. And as we work through these problems, I'm just going to refer to them as the calculus slope and the algebra slope. So calc slope equals alg slope is how I like to say it. But let's go ahead and just move on to the first example problem. So the first thing that we have to do on all these problems is basically to be able to recognize them as IVT or MVT. So when we look at this first one, show that there is a c between 0 and pi such that f of c equals 1. So I'm going to make this, Let me move myself before I move on to this next one. What I'm writing here is just that for MVT, you're trying to verify that the algebra slope equals the calculus slope. So like I was saying on this number 3 on the first example, what we're doing is showing that a c is between two numbers, and the c has a certain y value. So I'm going to call that one IVT because you're not trying to find a certain c, you're just trying to prove that it exists. So, okay. I'm just going to skip ahead a little bit. Okay, so I just skipped ahead a little bit here. Like I said, this number 3 is IVT, and with what we're given, the first thing that we have to do is we have to find the y values. Remember on that formula that you have to prove that a number is between two different y values, and in this case, you're given 0 and pi, you're given the x values, but you're not given those y values. So we need to find those first, and I'm just going to do that by plugging that in to f of x. So when I plug in 0, I get 0 plus 3 cosine of 0, which is going to equal 3. And then when I plug in pi, I am going to get pi plus 3 cosine of pi. So I'm going to write that out. And then that equals pi minus 3. So what I wrote out here is 3 is greater than 1 and pi minus 3 is less than 1. And that is just a way to show that it's between, to show that 1, that number that I circled here, is between these two y values. And you don't have to write that out every time. I'm just trying to show as much as I can on this first example. So the next thing that we have to do is just write out our sentence. Okay, I just skipped ahead to the end of the sentence so that I can show you what all this means. Basically what we're doing is using that template that we used on the very first problem and plugging in the numbers that we need for this one specifically. So I'm going to say by IVT, you always have to start with how you're proving it, either by IVT or by MVT. Because 1 is between f of 0 equals 3 and f of pi equals pi minus 3, so those are your y values. 1 is greater than 1 and the other one is less than 1, so 1 is between them. There is a c, there is an x value between the two given x values. Sorry, you can't see them, but there's 0 and pi, such that f of c, basically the y value of that c, equals 1. And if that sentence is still a little confusing, we're going to do a lot more example problems and you'll get the hang of it. So this next one that we're looking at, we're trying to show that there exists a c between 0 and 2, such that f prime of c equals 0, and we're trying to find that c. So because we're trying to find a certain number, then we know that this is MVT. Remember that with MVT, we're going to use derivatives, and we're trying to show that the calculus slope is the same as the algebra slope. So the first thing that we need to do here is, let's see. Okay, so I'm just labeling, that's our calculus slope, and we don't know our algebra slope. So we have to set up that equation. So to find our algebra slope, we're going to use those two x values that are given and do just our regular slope formula. So we're going to do f of 2 minus f of 0 over 2 minus 0. And I'm going to go ahead and solve that, and I'm using this f of x up here to get the numbers that I'm getting. And when I plug in 2 and 0, I'm going to end up getting 16 minus 16 when I plug in 2, minus 0 plus 0 when I plug in that 0 over 2, and that equals 0. And then we've already been given our calculus slope over here. It says f prime of c equals 0. And since those numbers match up, we know that we can prove with MVT that there exists a c in between those x values such that f prime of c equals 0. So what I'm doing here is I'm setting that algebra slope 0 equal to the calculus slope. And so at this point, I'm trying to actually find the c. So I already know that there exists a number. And when I find the c, I'm just going to take that f of x, and I'm actually plugging in c for x, but I'm keeping all of those numbers the same. And so what I did was I took that algebra slope and I'm setting it equal to the calculus slope. So to find the calculus slope, once you plug in c for x, you have to take the derivative of that function. So the derivative is 4c cubed minus 6c squared, and I'm just simplifying that and getting 2c squared times 2c minus 3. And I didn't show all my work for solving that, but when you solve it, you're going to get c equals 0 and 3/2. And so make sure on this problem, this is kind of tricky, that you only have one answer for your c. So in this case, we have a 0 and we have 3/2. But remember, like I said in number 2, that it has to be on a closed interval, which means that any number, if you have a number for your answer that is the same as one of these x values, it can't be that number because we're working with a closed interval. It can only be numbers between these two numbers. So I'm just going to cross out the 0 here, and my answer is actually going to be c equals 3/2. So remember, MVT is basically just setting calculus slope equal to algebra slope and making sure that they equal each other. And then if it asks you to find a c, then you're going to use your formula or your function and set it equal to that algebra slope to find the c. So in this case, we've got 3/2. Okay, so another way that MVT, IVT problems can be asked is like number 5, where you're trying to find which statements are true. So we're going to have a few MVT, IVT problems within this. So the first thing that we're trying to figure out if it's true is number 1. And that says, is it true that 4 has a solution in 1 to 5? So all we're doing is showing that there is a solution, and we're just working with f of x here, no derivatives, which means that we're going to be using IVT on this first problem. So remember, IVT is just showing that a number is in between two other numbers. So in this case, we're trying to find out if the y value of 4 is in between the y value of 1 and 5. So what I'm writing out here is f of 1 is -1, f of 5 is 15, and I'm just looking at my givens to get that information. And I know that 4 is in between -1 and 15, so that has to be true by IVT. And sorry, I said earlier y value of 4. 4 is a y value, and then these are your y values too, and it's between those. So that's true by IVT. The next one looks the same, except you've got f prime of x. And remember that if we have a derivative, we're going to be using MVT. So MVT is calculus slope equals algebra slope, making sure that those are equal. That's how you prove it. So we're going to just write all of that out. So the first thing that I need to write is I'm doing that algebra slope, f of 5 minus f of 1 over 5 minus 1, that's 4. And let me move my face up to this corner. So once I solve that, I'm going to get that algebra slope equals 4. And then I'm trying to make sure that that matches up with f prime of x. And that's given right here, f prime of x equals 4. So since those slopes equal each other, you don't have to do anything else. You already know that that part is true by MVT. And that's not like the question before, that number 4, because on this one you're not trying to find the c. You're just trying to say that f prime of x equals 4 has a solution. So all you have to do is set that calculus slope equal to the algebra slope, and if they're equal to each other, then that one is true. Now on this next one, now we have f double prime of x, and because IVT and MVT don't deal with second derivatives, you can't necessarily prove that number 3 is true. So since that one is not necessarily true, it's not true all the time, then we can't say that it's true. Okay, on these next few, we're going to be working with tables, but it's really not that different from the problem we just did. It's just that our givens are given to us in table form. So this first one is asking, we're trying to prove which statements are true. This first one is dealing with v of t, which is given in the table, and we're trying to find v of t equals 2 for some x value between 0 and 3. So just like on that problem before, or just like on the first example problem we did, we have to find our y values first so that we can be able to prove this. So I'm going to start by finding the y values. We're given our x values 0 and 3, so we need to find the y values that match up with those. So I'm going to go ahead and find v of 0, and the table tells us that that's 4. And then for v of 3, we've got -1. And our y value that is given here is 2. We're trying to make sure that 2 is in between those y values. And since it is, we know that this is true by IVT. And remember that first condition that has to be true is that the graph has to be continuous between your x values. And it's given in number 6 that v of t is a differentiable function. And since differentiability implies continuity, then we know that this can be true. Okay, on this next one, we are dealing with, let's see. So I was just writing out the steps that I did when I found IVT, or writing out the conditions that have to be true. The first condition being differentiability, and that, like I said, implies that it's a continuous function. Okay, so I just wrote out that sentence right there so you can see how the sentence fits into this problem. I said it's true by IVT. Remember, you have to say whether it's IVT or MVT because the velocity is continuous. Remember, we know it's continuous because it's differentiable. And 2 is in between f of 0 equals 4 and f of 3 equals -1. So you've got this y value is in between these two y values. So you know that there has to be a t that exists that has that y value too. Okay, so let's move on to the next one. On this one, we're dealing with a of t, which is the same thing as v prime of t. So since we're working with primes, since we're working with derivatives, we know that this has to be an MVT problem. So let's see if this will focus. Okay, there we go. So that's an MVT problem. So the first thing that we're going to do is take that calculus slope, and that's given, that's 1/2, and we're going to try to see if that 1/2 matches up with the algebra slope. So to get that algebra slope, we're going to take those numbers 3 and 9, find our slope, plugging it in to, or looking at the graph there. And so the slope there is 1/2, and that matches up with the calculus slope. So we know that there has to be a t that exists. And remember, it doesn't ask us to find the t, so it stops here. We just have to go ahead and write out our sentence. It's true by MVT. Okay, so this next one is another table problem, and it's pretty similar to the one we did before. So first thing that we're going to do, let me move myself. There we go. First thing that we're going to do is look at that number 1, and we're dealing with f of a. And so what we're doing here is using IVT because we're not dealing with derivatives. And I'm finding my y values like we've done on all these other IVT problems. And looking at my table, I know that my y values are 3 and 0. And this 2 that's given is between 3 and 0. So we know that it's true by IVT that there's an a that exists. Let me write this out. That there's an a that exists such that that f of a is between 3 and 0. Okay, so on this next one, just like on the one before, we're dealing with a derivative, so we know that it's an MVT problem. And so what we're trying to do here is checking and proving to see that the calculus slope using 4 and 6 is going to equal, or so that the algebra slope is going to equal 4, which is that calculus slope. So what I'm doing here is just using my table to find our algebra slope, and that's going to be 8 minus 0 over 2, and that's going to be 4. So that matches up with f prime of b equals 4. So we know that this is true by MVT, because that calculus slope equals the algebra slope. Remember that graph before, what we're saying is that the secant line and the tangent line are parallel. They have the same slopes. So if you want to go, as we're doing these examples, if you want to kind of go back to the beginning of the video and see how the work we're doing matches up with those examples, those kind of templates that we did on the first two, then I think that would be really helpful, especially looking at those graphs. Okay, so this next one, let's see. I see a derivative, so I'm going to try MVT. So what I'm doing is setting that calculus slope, f prime of c, equal to the algebra slope. And when I take those numbers on the graph, let me write that out, I'm going to get -1. And -1 does not equal 2, so that can't be true by MVT. But that doesn't mean we should stop, because we can still try to prove it through IVT. Even though that's a derivative, we're given the derivative values in this table, so we can still use them to try to prove using IVT. So let's do that. I'm basically going to do the same thing I do on any IVT problem, but, oh, here you go. But instead of using f of x values, I'm using f prime of x values. So I'm just going to kind of skip ahead to that. I looked at that table to find those f prime of x values. F prime of 1 equals 5, f prime of 4 equals -2. And then given right here, we have that f prime of c equals 2. And that 2 is between 5 and -2. So even though MVT doesn't work, this is true by IVT. And what I wrote on the side there is when MVT doesn't work, you use IVT with f prime. So same process, but you're using f prime instead of f of x. Can you read that? IVT is true because, you can't really see that, but it says because 2 is in between f prime of 1 equals 5 and f prime of 4 equals -2. 8 looks a little bit different. It's asking what's the fewest number of times that f prime of x equals 0. And even though this is kind of a different problem, we know that we're dealing with f prime, we're dealing with a derivative, so we know that we're going to be using MVT somehow. So on this kind of problem, one of the fewest number of times problems, we know that the algebra slope is going to equal the calculus slope at least 2 times usually. So in this case, we're trying to find out how many times at least that algebra slope equals the calculus slope. So we're going to have to do MVT, kind of do MVT twice. I'll show you once we get there. But what's important to know here is that you've got f prime of x equals 0, and you know that your slope equals 0 when y coordinates are the same. That's true because if you have 2 y coordinates that are the same and you draw a line between them, that slope's going to be 0. So this slope is going to be 0 when the y coordinates are the same. So in this table you can see that the y coordinates are the same when you've got that 5 and 5, and then you've also got an 8 and 8. So we're going to take the algebra slope twice using those numbers. So the first one I'm going to do is f prime of a, and in this one I'm focusing on that 5 and 5 that are the same. So I'm going to use 2 and 1 for my algebra slope, and that equals 0. Oops, sorry. That equals 0, so you know that MVT is true for that one. And then the next thing that I'm going to look at is that 8 and 8. So the numbers that I'm going to use in this case are 10 and 5. And I'm choosing these numbers because those are the intervals where those y coordinates are. So on the first one, that 5 is, or both of those 5s are in the interval 1 and 2. I hope you can see that. And then the 8s that equal each other are in that interval 5 and 10. That's how I chose those points. And so then when you do that, you're also going to get 0. So you've got algebra slope equals calculus slope there. You've got algebra slope equals calculus slope there. So you know that the fewest number of times that calculus slope equals the algebra slope is twice, because I found the 0 twice. Okay, so on this next one, we're going to be using the information that we did on part 1 to do part 2. And this is about as hard as IVT and MVT problems get. This one I know is kind of confusing, but usually they're more basic problems like the ones we've been doing earlier in the worksheet. So on this one, you have a double derivative, f double prime of x equals 0, and we're trying to show that that is true in that interval 1 to 10. So since we're using that double prime, since we're using that double prime, we know that it's going to be an MVT problem since we're dealing with derivatives, and we're trying to prove that calculus slope equals algebra slope. But remember that since that's double prime, on the algebra slope, we're actually going to be using the function f prime. So this is kind of confusing, but like I said, we're going to have to use that part 1 to help us with part 2. So what I did was calculus slope equals algebra slope, remembering to make sure that I have f prime as my function. And I am using these functions that I did in part 1 to help me with part 2 here. So I'm going to have 0 over 0, those are the numbers I found in part 1, over b minus a, and 0 divided by anything is 0. So we've already proven that that algebra slope equals the calculus slope. So in that case, we just did MVT with a double derivative, and let me move myself. And we made that algebra slope using that single derivative, that f prime function. So that is true by MVT. Okay, I hope that was helpful. I know IVT and MVT can be a little bit of a confusing topic, but the really important thing here is to make sure you understand number 1 and 2 on these worksheets, because those are kind of your templates for any example problem that you're going to be given. So you can find more review of MVT and IVT on some of the review worksheets later. And if you are doing one of those review worksheets and it's confusing, just remember you can always come back to this video. And if you found it helpful, like it and subscribe to this channel, and make sure you check out some of the other calculus videos that we have. Thank you.